Our next step is to make sure that we have a valid bill of materials for our project. This is really important because if our bill of materials isn't set up now, then if we do it after we send the board out for production, we might realize that lo and behold, the chip that we plan to use, the part we plan to use, isn't available. We can't get it in a timely fashion, or was wrong from what we expected it to be based upon what we ordered. So I always make sure the bill of materials is done and looks right just before I click send and send the board off for production. Bill of materials in KiCad is handled through the eSchema program. So here we have eSchema open up, and it's right here under this BOM button. Now by default, no bill of materials generator is available to you, so you have to add one in. There are many third-party bill of material generators out there if you do some Google searching. I tend to use the basic one that's already provided, so we're going to add the plugin. Here it's defaulting to my standard KiCad bin library. On Windows, I would then dive under scripting, plugins, and then I have a couple different bill of material generators. I like to use the bill of materials sorted by reference, so this is going to actually show each and every part so that I can't accidentally lose sight of one being there, like missing a part or not. The problem with this particular mode is that it's a little slower for me to actually add the parts into a company like DigiKey or something to order from, but I generally work with this one first. So I'm going to select that. I have to give it a name. I'm just going to leave it as the default name. There it is. This is actually a Python script that runs in the background. That was something that was installed when you installed KiCad, and it has a set of input options. One of the ones, and this was really confusing the first time I used it, is this last %O. This is going to be the name of the file that's generated, and by default it doesn't have an extension, and oftentimes browsers really hate that. So I wanted to go ahead and add a .csv within the quotes after the %O command there. And then from here I should be able to click generate, and it runs the command. It does its thing. It successfully did it. So we'll go ahead and we'll browse over and we'll look at that. Here I have my file, and there it is, that v1.csv. I can open that thing up, and I get something like this. So this is opened up in Excel. In this particular case, you'll see I have all my different values, and again, as I mentioned, they're split up by reference. I have their footprints that are going to be used, and then I have columns for datasheet, manufacturer, and vendor, and you'll notice these are all blank. This is because by default parts are vendorless. They're manufacturer independent, and we'll have to add that information in order to get this to populate properly. So let's talk about how to do that. Just going to go ahead and grab this thing. One of the things that's really annoying is that we're going to be creating some new fields for our parts, and if we create those fields with slightly misspelled names, this is just, it's not going to populate these columns like it should. So we want to make sure we have that right. So what I'm going to do is I'm going to pop over to our tool itself, and I am going to show how we would fix this. So for example, on this Mega 48 part, I would jump to edit. These are the current fields that are available, but you'll notice there's nothing that says vendor or manufacturer. So we're actually going to add a new field that we're going to call vendor, and then we're going to add another field that we're going to call manufacturer. Okay, so now we have those two spots available in the Mega 48. Then we need to go grab the actual part numbers from the DigiKey or from wherever it is. And so in this case here, we're looking at a 18 Mega 48 AU4ND. This is a 32-pin TQFP. This is the part that it's also cut tape, meaning I can buy them in small quantities. Yes, so this is the part that I want. So I'm going to copy the manufacturer's part number over, and in my tool I'm going to change the manufacturer part number to be that number. Hit enter. Okay. Okay, and then let's jump here to vendor. And for vendor, I usually put the vendor part number, the actual part I would use to order this component. So in that case, it is this number here. Oops, sorry, you have to enter it down there. And then this is datasheet. And what's really cool about this is this actually allows us to put it in an HTML link directly, that we can go out to the datasheet directly. That's really useful so that you kind of keep everything all in one place. Using in a company like DigiKey or Newark or the big distributors, odds are this reference, this page will probably never change. And the odds are slightly less, though, that the direct link to the datasheet will probably never change. I'm going to go ahead, though, and try to grab the exact, no, I'm not. I'm going to just grab this part here at the top. And that's what I'm going to drop into for this field. Okay, so that's all populated. Great. So now if I save this, and then I try to generate the bill of materials from it, then I try to open that, we should find that that's been populated, at least that one column, with, and there it is. It's kind of hard to see in this current format, but I'll spread it out. There's the datasheet link. There. Here is the manufacturer and the vendor. I did tweak another one of the parts that was available for us, just for one of these 6-pin mail headers a little earlier. But basically, we just have to do this process to fill it out. It is per part, so it is kind of a bit obnoxious at this point to go back over a lot of the parts we already have, but it's worth the effort. In starting from scratch, one way I might handle this is I might actually start by making each of the parts I'm going to be using and then just copying it once the information's been filled out. But this isn't too much work, and once it's done, it never has to be completed again. So I'm going to go ahead and go back to fast forward while I run through and finish off this bill of materials. So this is already super tedious, and I don't want to do it this way anymore. So I went ahead and I dug around on the web, and I found this tool, which is called KiCad. Here you can see it there in the corner, and I thought that I would probably use this tool to kind of move forward on what I want to accomplish. And so I downloaded it, I installed it. It's Python based, but basically what I did is I ran a command here where I used KiCad to extract from my schematic the design fields and put it in a CSV file. And so you can see that CSV file here when I pop the right spot open. Right here, I made a couple different versions of it, but here's one that I've got in place. And you can see that it pretty much gives me the same type of an output as the bill of materials that I've already done. But the nice thing about this KiCad is there's another command that I can do, and it'll feed this information back into the schematic. That way I don't have to keep two versions around. I know that my schematic has all the information and is accurate, so that I can always regenerate the bill of materials from the schematic. So I'm going to actually use this for doing my work next. And I'll enter all the data here and then I'll upload it. So that's what I'm going to do. So here's an example of why we double check this. So I don't remember exactly how I ended up choosing this crystal originally, but it's definitely not the crystal I'm expecting, and I'm having trouble finding the exact match for it. I do have a different crystal specified, so I'm going to look that part up, and then I'm actually going to change the footprint in our design to match this part. So yeah, if I'm going to use this part, I'm going to switch to an HC49 style case, which is this kind of little metal can with this particular height and width, which is a standard size in our library. I don't know what I was doing when I was originally trying to make this assignment happen. But 7 by 4.1, one last time to confirm, 7 by 4.1. Great. Okay, so we're going to switch it to this. And that means that I'll have to do a regeneration of the net list, an update of the parts, et cetera, and then a redoing the DRC check. But I am going to finish adding the bill of materials first and getting that uploaded all in one fell swoop. So. Okay, so this is done, designfields.csv. I'm going to go ahead and I'm going to save this. I'm going to leave it as a CSV file. I'm not going to let it make any other tweaks to it. I'm going to trust Excel, well, that's a scary thing to say, to not mess up my standard CSV file. But we'll see what happens with it. From here, the next step would be then to re-import this. And so to import this file, I need to type in a command that looks something like this right here. Well, I put them in Excel spreadsheet, excuse me. Something like this here to import them back into my design. And so I had some different names here. So I had V1 instead of my. And then the design schematic was V1. Okay, before I click this, because it's the first time I've used it, I'm going to make sure that I have a backup of my files. So I'm going to do that real quick off camera, and I'll be right back. Okay, and we're back, so let's see if this makes me cry. So I didn't like that so much. I do seem to recall there was something here about just to make sure. Okay, well, that was kind of a nightmare. Well, it wasn't really that bad. Remember, I kind of made that silly comment about Excel not doing me wrong. That was incorrect. So the problem was that in order to process a CSV in Excel, what tends to happen is Excel puts quotes into what's going on. So for example, here is the file open in Notepad, and I'm just going to undo what I just did. And so what happened is Excel said, hey, I have this quote here, this single set of double quotes. So for your reference, this is these particular headers here. Opening up our schematic. It's these 0.1 inch headers. For a lot of these, what I've done is I've selected the 0.1 inch header spacing, which looks like at some point it'll load. Looks something like these. So these are the headers and the connectors. But then in the text itself, the property that I'm using for these is this one. Where the actual name at one point had a, oh, this is the wrong part. Of course, I picked the one part that's not that way. Has this 0.1 inch in here. So when Excel saw this, it went crazy on these lines. and it inserted a bunch of extra double quotes, and then it escaped one of them, and it filled these lines with basically non-standard CSV. I know why it did it. It did it because it assumed that my CSV file was quote enclosed when it wasn't, and then it was different line by line. But net effect, then when I tried to load it back in, it didn't work. But once I removed these and I went to something that looked like this, where I did still have the escape of the one double quote, but I didn't have the surrounding double quotes, this file right here was able to be loaded back in. With that loaded back in, you can see that I've got my information in place. I did it manually, so I don't have to actually, or through the Excel, so I don't have to do it all by hand, one by one. So that wasn't so bad at the end of the day, and I'll probably use that methodology again in the future. Okay, but there is one thing that we still got wrong here. This crystal, I think, is still the wrong format. The manufacturer and the vendor is correct, but the footprint is not properly assigned. So we're going to go ahead and assign a footprint to it. Now we're done. So I know that this is kind of a pretty long process, but I've kind of showed you the version without me having done it a million times and refining every possible thing so there are no errors. Because realistically, if you were doing something like this, you would run into some of these same errors. Arguably, a lot of them are silly errors, but you're still going to run into them. And so seeing how those could be handled and seeing some of them kind of ahead of you running into them can be pretty helpful. So that's why I chose to do it this way. Last thing is, let's open up our PCB, and then we'll make sure that we've imported that net list. Okay, so we'll bring that in. It did find that it needs to replace just the crystal, which it's going to do, and it did that. Okay. And if we zoom in here, sure enough, that crystal is very different than what it was before. So we're probably going to have to mess with that. I'm going to get rid of the fills, so it's a little easier. Luckily for us, it's about the same size as the other component, X and Y, but only has the two larger pads. So we'll still have to bump this around to get it right. Okay, now we are done. We have every part installed. We have our bill of materials complete. Just to verify that, we should probably generate one just to see if it comes out right using our technique. But basically, we're done and ready to ship this thing off. So if we run our bill of materials, add that plug-in back in. Remember, I was suggesting you add a .csv to the end. There you go, generate. Close that up. And we go look at that. That was v1.csv. Here it is, fully populated, ready to go, ready to buy all of these parts. Nothing's missing that needs to be included. So assuming I did my data entry right and I picked parts that make sense, I'm ready to make this board. Last video we're going to do is just a few moments. We're actually going to order these using Oshpark. All right.